much Solana code when you're doing auditing.
Nice. All right. We're going to slideshow this. Oh, also it's recording, so that's nice. Let me just make sure. I'm just
Where do the Solana companies get their money from? How do they show us so much money to pay for auditing?
Wait, what happened to Solana?
It's
Do they,
dropping like all crypto is.
It's like inflating right now.
They get it from NFTs.
So true.
Yeah, they NFT all their assets, so no one can take them. Let's Okay. Hello, everyone.
Everyone.
Everyone. Emphasis on the one. Welcome to our traits workshop. No announcements. All right, Jason.
Alright, what is a trait? It's like the Rust equivalent of a class. You can define methods, constants, and associated types. So this is an associated type, right? So this is sort of unique. You can have types bound to traits. This is a constant, and this is a method. Note the use of the self type here. The self type is a type implementing the trait. And this is how you get an associated type. And this is an example of an implementation. So sort of like structs, you use impl, but you say impl foo, so the trait for bar. And this is defining the associated type, the constant, and the function. And also note that also, unlike some languages, you can put static methods in your trait. So if you just don't have the self receiver here, it will be a static method.
Wait, sorry. It was this. Oh, so then it wouldn't.
You just
without the self, it wouldn't.
Yeah.
Okay.
And then traits versus classes. You can implement multiple traits at the same time. Traits are not meant to uphold OOP principles of inheritance. And so all of this means that traits are sort of more like interfaces in Java, but better. And again, one struct can implement multiple traits.
Okay, so this is an example for your toy projects. If you want to explore the explore your knowledge of traits, you can implement a structure called rector, which I called rector, which its purpose is to iterate through a directory recursively, because part of your toy product spec is that if you give your CLI app a path name to a directory, it'll count all the lines of all the files in that directory, so recursive, right? And then what I did is I gave this structure a stack to hold the paths, and then entries to hold the current directory. And then because I wanted to so my idea was that instead of worrying about searching through directories in my main function, I wanted this rector itself to be iterable, so I can just use a for loop or a while loop on it. So to do that, I would implement an iterator trait for rector. And here is the implementation for that. So once I implement iterator for rector, I can use it in a for loop or in a while loop or a call next to it. So then the first thing I need to do is define the type of the item in the iterator, so what items this iterator is going to give me. And in this case, it's a path buffer, which is a structure that represents a file path. And then the next function, in order to implement iterator, I also need to implement a next function for rector. And then this next function takes a self reference and then returns an optional object of type item, which is again pathbus, as we define up here. And then this next function, its purpose will be to search through the directory recursively. So if there is some entry in the directory, and if that entry in our current directory is itself a directory, then we're going to push that path into our stack, so we know to come back to it later. And then otherwise, then we're going to return that path. If we if there's nothing left in our current directory, then we pop the stack and go on to the next directory. And then even if our stack is also depleted, then we return none to signal that there is nothing left in the search. And then tell recursion here. And then here's how we would use it. Don't worry about like the arc stuff. We're gonna talk about
Yes, classic Rust arc mutex vector.
yeah, we're gonna talk about parallelism another week. But the idea is that we initiate a recursive directory, and then I call it file iterator. So then I would use this file iterator here, like so. File iterator. Don't worry about the .log. This .log is because there's an arc, and then the .unwrap is because of mutex. If you ignore these, then we're pretty much just calling file iterator .next in a loop that loops forever. So it would consume each file until there's no more left, until this guy returns none. So as you can see, if file iterator .next returns and the return value is none, then we exit this thread by returning.
I feel like this could be a lot easier now with the thread scoped API.
Oh, that's true. How would you rewrite this then?
I'm assuming you're like joining all the handles at the
Yeah,
end, right?
yeah.
So instead, you could like put it in like a thread scoped, and then you can just like spawn the thread on the scoped one, and then I think that also lets you get rid of the arc. Not sure. At least you don't have to clone the arc for every single one.
Oh, okay.
Why would like locking a mutex fail?
So there's this concept of a poisoned mutex, and the idea is if a thread panics while like holding a lock, the like contents of the mutex are in a safe but unspecified state. So like you technically, the error variant of lock actually lets you get the value of the mutex, but like it's not guaranteed to be valid. Alright, now using traits, generic bounds. So you can like bound a generic, because I guess like it's called bound and not bind, right? You can bound a generic by using this like colon syntax, and this is basically saying any T that implements foo, this function will work, and we use a lot of things. We use the associated type, we use a constant, we use a method. You can also use where bounds in order to be more flexible. So here we're like bounding, I get bounding, not binding, whatever. We're bounding like this tuple tk to be debug, which you could not do with the colon syntax, because like what would you put the colon on, right? It's like if you have any bound that is not just like a simple generic type, you have to use where. And notice this is like how the Rust formatter automatically styles it. So I guess this is like the canonical indentation for how to use where.
Wait, seriously? That looks so
Yeah. I mean, it looks a bit better if you have like more lines here.
I guess like if you think about it, like binding is like when you assign a value, right? And bounding is like restricting a value. So I think that makes sense.
And now you can also use traits to conditionally implement methods. So you notice I put a bound on like the generic of the impl to be debug, and so now this print inner method will only exist on instances of foo where the inner type is debug. And this actually exists in the standard library in a couple of places, notably result.unwrap, I think result.unwrap, or is it expect? I think result.expect is only defined on results where the error implements debug, because expect like prints the error message out. So that's interesting. Unwrap maybe also does that.
Wait, how is this conditionally implemented?
You put the bound on like the impl. And then Rust has like coherence and orphan rules, which are like really weird names. But basically, it would be very bad to have two overlapping impls. So Rust will error if any two impls have even the potential to be overlapping, even if they are not immediately overlapping. So here there's an example at the bottom. Like this is impling foo for everything that is trait 1 and impling foo for everything that is trait 2. Even though there's like no type that is trait 1 and trait 2 right now, they could be overlapping because you could hypothetically add in a type later that implements both these traits, and that would break. So this is not allowed. Also, this is known as a blanket implementation because you're implementing a trait for like every type that already implements a trait. So yeah, that's kind of interesting. And then in order to ensure that there are no conflicting implementations, either the type or the trait must be defined in the current crate. So you could not implement like clone for vectors of ints because, you know, like if you have 2 crates that do that, then they have conflicting implementations, right? So this is sort of to get around like the C++ thing where anyone can define anything they want, and then, you know, when you import multiple libraries, like everything crashes and burns. And then if you do want to implement an external trait on an external type, you can consider using the new type idiom. I've included a link. I won't go too much in detail, but it's basically defining a new 1-element tuple struct so that it is your type and you can implement traits on it. And then there are also generic traits. You can have traits be generics. The most notable example of this is the into trait. Also, like technically the from trait, and you should implement from instead of into, since into is automatically implemented for everything that implements from. But like I thought that into looks clearer in this case, so we're doing that.
Would you be able to like implement from and into separately though? Like no. You
Yeah.
can't.
Wait, so those just do conversion?
What?
You like from and into just do conversion?
Yeah.
So like if you do as, would that do like your
As is not the same as from and into. As is for primitive cast only, like numeric cast, deref coercion, and trait object casting, I think are the uses for as.
Wait, so if you implementing into U8 for bar means that you are able to convert bar into U8.
Yeah.
Right. So if you could you implement a from U8 for bar that does something else?
Well,
Like maybe-
yeah, I mean, because those are separate things, right? Like
Okay.
from U8 for bar would be converting from U8 to bar, while this is the other way around. Like you could not like impl into U8 for bar and then impl from bar for U8 because those do the same thing.
Oh, right.
And also in general, you should always implement from and not into because from automatically generates an into impl. Because there's a blanket implementation for into for everything.
but not the other way.
Yeah, because you can't have like two-way blanket implementations because those could like contradict.
Right. Okay.
Right, so like if you implement the from for your own type, so like let's say you want to like make your type convert into some existing type, then like it's like it would be like import from your own type for some existing type.
Yes.
So like is that legal because like your type is like a
It-
generic argument for the from?
Yeah, it is legal because there's like this very like nuanced thing. There's like a very long write-up on the like exact specific rules, but basically, I believe if any generic type in the trait is your type, then you are allowed. Or no, that's not true. If all type, no. Whatever, it works.
I guess like maybe you can experiment with it in your own code. Like, what were you trying to do? Like implement something for vector, which is in the standard library.
I mean, if there's only one generic trait, okay, so if all generic traits are either, like, if all generic traits are your types, then it will obviously work. And then I'm not sure about the other cases. Anyway, generic traits versus associated types. You may notice they like kind of do similar things, but there are differences. You can have arbitrarily many generic traits for any given type, but you can only have one associated type for any given implementation, which means an associated type is sort of like a canonical type for that trait implementation, while generic traits are saying like, just do whatever works. So which one of these do you think is most useful? And the context is you're trying to create some like collection trait where like the only API you have right now is you can get the items as a vector.
Generic trait.
No, it.
Wait. Oh, wait. Oh, yeah, okay, yeah.
Because the generic
Yeah,
trait
okay.
is implying that you could have,
multiple,
like
same type.
the same type could be a collection of multiple different types, which is not particularly useful and can also be like actively obnoxious to use because there's like no canonical like inner type. So associated type is the way to go in this case. And this is very similar to the iterator trait in Rust, which is also using an associated item type.
Yeah,
so you
actually we
cannot
did
be an
do that
iterator
there.
of like.
We did do, over here. There's the associated type.
Yeah. And then like a good example of a generic type, like a good generic trait would be from and into, as we covered before, because you can convert into multiple things. It would make no sense to only be able to convert to one thing. And then implementing traits for generics, like it's the same as in structs. You just use like two generics, and you can put bounds here if you want. Common built-in traits. There are a lot. I encourage you to read the documentation on these. But debug and display, which are not like implemented into the prelude, but are still like very useful. Debug is anything that can be printed with like the colon question mark. Display is for things that can be printed with just the braces. The difference being debug is just, like debug output, but display is for anything that has like a canonical formatting. So like integers implement display because, there's like one like proper way to print out an integer, right? Like characters implement display because there's one proper way to print out a character. Like tuples do not implement display because like how do you print out a tuple? And then like into as well as from, we covered that before, it's conversion. Partial ec is for types that can be compared with like double equals. And there's also a marker trait that you might see titled just ec, which is not necessary to be compared with double equals, but it's basically saying that your like equality is actually like a equivalence relation, as in it's symmetric, transitive, and reflexive. So an example of something that implements partial ec but not ec is floating points, and I'm pretty sure that's the only reason why they created the ec trait. Because NaN is not equal to NaN, therefore it's not reflexive. I think that's the only thing in the entire standard library, and the entire reason why they made that.
Wait, so should we use partial ec or ec usually?
I mean, you should bound on partial ec, but like, if your type does actually have, proper equality, which most types should, you should always like derive ec as possible.
So use ec for your own types, but when your functions need some parameters, you should assume those parameters are only partial ec.
Yeah, unless you like actually need it to be an equivalence relation, then you should use ec. Because like it's this philosophy of like, accept the broadest thing while accept the broadest things while like providing the most.
Okay. Yeah.
So like you should be very strict on what your own types implement and like implement as much as possible, but you should, require the types you take in to implement as little as possible. And then clone are things that can be cloned, copy are things that can be copied, and default are things that have a default value. And then there's like a lot more traits that you can look up.
Okay,
I think we already did
I
this.
think we already
Let's
did
just.
this. Alright. Okay, so let me just talk about the core users project for those of you. I know, please like, comment, and subscribe if you're watching this video. I would really appreciate that. Anyways, for those of us that are here, and as well as anyone who's watching this, Let's go over some core util stuff. I talked a little bit about this last week, but I didn't really get it on video, so I'll just repeat it now. So there's a link to the repository. It's also in the core utils channel on the Discord. The test coverage summary. Oh, this is not on the channel, but here's the test coverage summary. If you click on this link, it'll take you to this bar graph of every single utility, as well as how many tests there are passing, erroring, and failing on. And then the red are what we're trying to target now.
MV is struggling.
MV is really struggling. I mean, MV is such an important utility that.
Or what's the one below that?
The one below that is PR, which is a utility for
Making a GitHub pull.
No. I wish it were, but it's actually a utility for formatting your text files so that they can be sent to a printer. So like breaking up your text files into pages that fit on like paper sizes and stuff. And there's only one test case for this, and that one test case is failing. But this is actually a very annoying test case because I looked at it. It was like a few hundred lines of Perl code and a few hundred lines of regex. It does actually look kind of painful, which is maybe the reason why no one has bothered to fix that yet. But yeah, MV, PR is also struggling. Touch is actually also struggling. So you can look at all the test cases here. Okay, so in order to run GNU tests, so in order to contribute to this project, you'll need to install cargo deny. For cargo deny, this one you should install using cargo in your core utils directory. So after you clone this, go into the repository and then install cargo deny using cargo. And then you also need to install these 5 things. In my experience, I don't think, maybe if you have even less packages, you might need to install even more things. But in my experience, these are the 5 packages that most people would need to install: libse Linux, Clang, gperf, rsync, and wget. Okay, so now that you have installed these things, let's talk about the test cases. So cargo test versus GNU test. Cargo test runs test cases under the test directory in the repository, but these are not actually really comprehensive. So even though the README says you can use cargo test to run tests, those tests are actually not comprehensive, so don't ignore that part. In order to ensure compatibility with GNU core utils, we must run GNU tests. And then see comparing with GNU in the README for instructions on how to do that. And then here is an example of me running the GNU tests. So first, these are commands that are copied from the README. So in this link over here, comparing with GNU, this comparing with GNU section, I'm just going to run through that section with you real quick. So first I do, in the repository directory, I do bash util / build gnu.sh. And then it says this, and then it says cannot find GNU, because at this point I have not cloned the GNU core utils repository yet. And it tells me that I should clone that repository in order to proceed. So I do that, git clone, I just copy the command that they recommended, git clone GNU core utils into home/json/projects/GNU. And then once it's done cloning, I try again. I just run the build gnu.sh again, and then it'll work this time. Now, once build gnu.sh has finished running, now you're ready to build GNU tests. GNU tests are found in the GNU core utils repo. So in my case, since I cloned it into home JSON projects GNU, it'll be in that/test/touch/not-owner.sh. That is one test case. To run a single test, go to the Rust core utils repo. So this command will be executed in the Rust core utils one, not the GNU one. So the GNU one is GNU, and the Rust core utils is core utils. So then I would run this bash util / this command, and then for example, to run this test case up here, I would run this command. I would recommend running one test at a time because running all tests at the same time is resource intensive and has led to out of memory error for me. And then this is an example of me running the not owner test case for touch. I run it and then make does some stuff, and then now it's all green and it passes. That's great. And actually, if you run some of these test cases, right, some of these red ones, for example, mv special one.log, this one, if you can try to run this one yourself, it should probably fail.
Probably.
Unless that one's out of date, but the coverage summary is usually up to date. It's updated like every day, so that's why I said probably. Anyways. Oh, is that it? Okay. I guess that's it. Okay, so again, if you have any questions about the Core Ethos project, please ask on the Core Ethos channel. Okay, that's it for the presentation. Thank you for watching and coming to the meeting.